the shape of the Earth, round or flat? It's a question that sparks curiosity, debate, and even passion. But today, we're not here to argue or pick sides. Instead, let's explore what science tells us about this fascinating topic. Since the dawn of time, humanity has gazed up at the heavens and down at the earth beneath our feet, questioning the very nature of our world. Is it a boundless plain stretching endlessly in all directions, or a massive sphere spinning silently in the vastness of space? This isn't just a modern debate, it's a question that has intrigued great thinkers for centuries, from ancient philosophers to today's scientists. But here's the twist: instead of arguing over who's right, let's dive into the evidence. How do ships, sunsets, and even the moon itself reveal the truth about Earth's shape? Grab your curiosity and let's embark on this journey together, exploring one of humanity's most fundamental mysteries. Observations from everyday life. Let's start with something simple. What happens when a ship sails into the distance? If you've ever watched closely, you'll notice the hull disappears first, followed by the mast. This happens because the Earth's surface curves, gradually hiding the ship from view. On a flat surface, the entire ship would just get smaller but stay fully visible. The same applies to sunsets. On a round Earth, the sun appears to dip below the horizon because the Earth is curving away. On a flat plane, the sun would simply fade into the distance, shrinking in size. The shadow of the Earth. Now, let's look to the moon. During a lunar eclipse, Earth casts a shadow on the moon. No matter where or when this happens, the shadow is always round. A sphere is the only shape that can produce a consistent round shadow from any angle. Satellite orbits and gravity. Satellites provide another clue. They orbit Earth because of gravity, which pulls them toward the planet's center. This consistent pull works because Earth is round. On a flat Earth, gravity wouldn't behave the same way, and stable orbits would be impossible. What about flat Earth perspectives? Now, let's consider some flat Earth perspectives. For example, many flat Earth models suggest the Earth is a disk with the Arctic at the center and Antarctica forming a boundary around the edges. They argue that phenomena like the horizon at eye level or the lack of visible curvature from the ground support their view. But science offers alternative explanations. The horizon appears at eye level because of how our perspective works with a curved surface, something we can test at high altitudes, like in a plane or with a weather balloon. Let's explore flat and round Earth perspectives. Imagine the Earth as a pancake, flat and straight. If you're standing on it, the horizon, where the land meets the sky, will always appear at the same level as your eyes, no matter how high you go. It's like a never-ending flat line. Now let's explore the round Earth. Think of the Earth as a big, round basketball. When you're on its curved surface, the horizon seems to drop slightly as you go higher. For example, when you're on a mountain, in an airplane, or sending up a weather balloon, the horizon doesn't stay at eye level, it dips lower. This happens because you're seeing the curve of the Earth from up high. The cool part? You can test this yourself. Next time you're on a plane, notice how the horizon doesn't stay perfectly straight. It's proof you're living on a giant, beautiful sphere. Here's a simple experiment you can try. Place 2 sticks in the ground at different locations and measure their shadows at the same time of day. If the Earth is round, the shadows will have different lengths because of its curvature. This is the same method ancient Greek philosopher Eratosthenes used over 2,000 years ago to estimate the Earth's size. What we see from space. From the vantage point of the International Space Station, ISS, astronauts get an awe-inspiring view of our planet, a glowing, round sphere filled with vibrant colors of blue oceans, green forests, golden deserts, and white clouds. It's a perspective that has been confirmed by countless people who've been to space, regardless of their nationality or mission. Satellites orbiting Earth continuously capture similar imagery, revealing its curved shape as it transitions from daylight to night across different regions. This curvature becomes even more evident during solar eclipses, where the shadow of the moon moves in a curved path across the Earth's surface. While some people doubt the authenticity of this footage, it's essential to note that these views aren't limited to NASA or any single organization. Independent space agencies and private companies worldwide, like the European Space Agency, ESA, Roscosmos, Russia, JAXA, Japan, and others, have recorded similar evidence. Even amateur astronomers and weather balloon enthusiasts have documented Earth's curve with their own equipment. While some question the authenticity of this footage, it's worth noting that independent organizations and countries have taken similar image. So why do flat Earth theories persist? Historically, early civilizations believed in a flat Earth, based on their observations and cultural narratives. Even after science confirmed a spherical Earth, the idea of questioning established knowledge has remained appealing to some. The bigger picture. Whether you're a fan of flat Earth theories or firmly believe in a round Earth, one thing's clear: curiosity and questioning lead us to fascinating discoveries. Science gives us tools to explore, test, and learn more about the world we live in. In the end, the evidence points strongly to Earth being a round, dynamic sphere. But the journey of exploring these ideas teaches us something even more important: how to think critically, investigate, and stay curious. Thanks for joining me on this exploration. Don't forget to like, comment, subscribe, and keep asking questions.